Pamela and Gail were puzzled. They needed 500 milliliters of solution that was 14% salt. So let's focus on that statement. They needed 500 milliliters of a 14% salt solution. So that's their end result. That's what they want to come up with. So if I'm making these boxes, we're mixing two together. How much of each solution should they use? So mixing solution 1 and solution 2 to create some end result. End result is what we're trying to get. So we want 500 milliliters of a 14% salt solution. Okay. This percentage is about salt, so we need to focus on salt percentages as we go. What they have on hand is a 10% and a 20% salt solution. That's what we're mixing together. 10% is too weak and 20% is too strong. We're looking for something in between. And it says how much of each should they use. We don't know either one of these amounts. So we make one of those amounts x, the other one's going to be what we're looking for minus x. So if this is 100, 500 minus 100 is 400, 100 plus 400 makes 500. So that's how we do this. We know the total we want, total minus what we've already used is what's left over for the second one. Once I get all the boxes filled in, this product 10x plus this product 20 times 500 is 10,000. And 20 times x makes minus 20x. And 14 times 500 is 7,000. So this times this, this times this, this times this. This one's a binomial, so distributive property necessary. I'm going to move the 10,000 over to the other side. Over here, 10x minus 20x makes negative 10x. Over there, 7,000 minus 10,000 makes negative 3,000. We divide by negative 10, we get x equals 300. X represents the 10% salt, so I need to establish the answer for both. How much of each should they use? So we need some amount of 10% salt and some amount of 20% salt. Again, X represents this, which is 10%, so 300 goes here, that's milliliters. And then 500 minus 300 is 200 of the 20%. And there's my two answers. Number 2. The riverboat Emily Eleanor could go 152 miles downstream in 8 hours, but it took her 14 hours to go 126 miles upstream. What was her speed in still water? And what was the speed of the current of the river? So, the first thing we want to focus on in a boat in the river problem is how fast they can go in still water, how fast the water is, and they don't tell us either one of those two things. So, I'm going to say B equals speed of boat, and C is equal to speed of current. Okay, we always want to start off with that. Either write down the numerical value for both of those, or assign a variable to both of them. And then we create this rate time distance chart. With upstream and downstream as our categories. The rates are always boat plus current for downstream and boat minus current for upstream. We happen to know exact amount of time. The downstream time is 8 hours and the upstream time is 14 hours. We know the exact distances. 152 miles is the downstream distance and 126 miles is the upstream distance. Now, for these specifically, when you don't know either of these two numbers, we know the rates, the times of the distances, so we can find out the rates. So, if I do 126 divided by 14, that equals 9 miles per hour. That's the upstream rate. If I do 152 divided by 8, that makes 19 miles per hour. That's the downstream rate. Okay, so these particular ones where you don't know either of these, they're the easiest you can get because you know all these numbers here, distance divided by time equals rate. So then I just create a real simple system of equations here. I got the upstream B minus C equals 9, the downstream B plus C is equal to 19. My job is to figure out how fast the boat can go B, what's the speed of the current C. And this is a simple system of equations. Minus C and plus C are going to cancel if I add them together, so B plus B is 2B. Minus C plus C cancels. 9 plus 19 makes 28. That makes B equal to 14. So B, boat, is 14 miles per hour. And C for current Wants to know b is equal to 14. I just have to ask myself 14 plus what equals 19? That'd be 5. We tested out 14 minus 5 makes 9, 14 plus 5 makes 19. We already knew those rates were the right rates, so that's the correct answers to the problem. Number 3, at the bazaar, Deeb paid the Burke $1,600 for the rug. The Burke had only paid $1,000 for the rug. What was the markup as a percentage of cost? Cost is purchase price. All right. So what we know when we see these markup problems, we know we want to establish the purchase price, the selling price, and the markup. Okay. So what Deeb paid is the selling price. The Burke had paid $1,000 for the rug. That's the purchase price. If you're not sure, the selling price is always more than the purchase price. So if you're not sure which is which, I mean, Deeb is a weird name. The Burke, that's an actual seller of goods in a marketplace in probably some Arabic country, my guess, based on the way this looks. But the selling price is always more than the purchase price. Otherwise, you're running a bad business. You pay money for something. You pay $10 for something. You sell it for $3. You're not going to be making any money. So you're going to sell it for more than you're purchasing it for. And we can see very clearly the markup is $600. All right. So that's $600 more than that. So we got all three of these numbers as we wish. Now, what markup is always it's a percentage of one of these two numbers, and specifically this time we want the purchase price. So what I'm going to do is I'm going to say the markup is some percentage of the purchase price. So what the actual markup is equals a percentage as a decimal, I don't know yet, times the purchase price which they've given to me. So if I solve this, I get P is equal to 0.60, and that's just 60%. That's what we're looking for. So I'm going to word it pretty much the same way, same type of structure. Markup's not going to be 60% probably, but you'll get some numbers, you'll get these two numbers here. You'll be trying to find what the markup is, whatever that is, and then that. So get a decimal and change it to a percent. Number 4, show that 0.03512 with the 1, 2 repeating is rational. So what we want to do here is start off by naming that x. Leave yourself some space. 03512 with the bar over the 1, 2. There's 2 digits repeating, so I'm going to multiply by 100. If there was 3 digits, 1,000, 4 digits, 10,000, and so on. The power of 10, so 10 to the second power is 100. So 100x times 100 moves the decimal point 2 spaces over. That's going to make 3.512. The repeating bar could go there, but I want to do one extra 1, 2 with the repeating bar there, so all my repeating stuff lines up. Subtract, subtract. And then you get what you get when you subtract. So 100x minus 1x makes 99x. 3.51212 repeating with minus 0.03512 repeating. The 2's and the 1's repeat all the way to infinity and subtract, so we're left with just this nice simple subtraction. Make that a 0, borrow, we get 12 minus 5 is 7. Borrow here, make that a 10. 10 minus 3 is 7. 4 minus 0 is 4, and 3 minus 0 is 3. So 99x equals 3.477. I divide both sides by 99, but over here I'm going to make it 99.000, the matching number of decimal places. So I get 3,477 over 99,000. All that's left to do now, that's the correct answer for half credit if it reduces. If it doesn't reduce, you're done, that's full credit. But we need to see if this reduces. So if we take a look at 99,000, just worry about the 99 part. That's 9 times 11. 9 is 3 times 3. 11 is prime. 1,000 is 3 2's and 3 5's. 10 times 10 times 10, so that's what it is. So all I have to do is ask myself, does this number divide by any of these numbers? I'm going to start with the obvious ones that don't work. It doesn't end in 0 or 5, so 5 doesn't divide it. Doesn't end in an even number, so 2 doesn't divide it. I don't know about 11, so if I try 3,477 divided by 11, it comes out to a decimal, so 11 doesn't. If I do 3,477 divided by 3, I get 1159. So it does reduce by 3. Try 3 again, it doesn't. So it only divides by 3. So one of the 3's worked, the other one didn't. So to reduce it, I'm just going to divide both top and bottom by 3. Dividing the top by 3, of course, gets me 1159. That's what my calculator said. If you don't know what 99,000 divided by 3 is, you can type in your calculator. Happens to equal 33,000. That's the full credit answer. Again, that's the half credit answer. And you can always check these really easily. If you type in 1159 divided by 33000, type in your answer as a quotient, 0.035121212, and so on. You can see that the number we started off with is the same as what we have on our calculator. That represents that that is the same as that, and that's what we're looking to do. Number 5, long division with more than one variable. So we're dividing by x plus y, that goes outside. We're dividing into x cubed plus y cubed, that goes inside. And I'm going to leave myself plenty of space here to account for terms that don't match y cubed. So x cubed is in front, some terms happen in the middle we're not sure about, y cubed is at the end, and it's plus y cubed, so that goes on there, over there. It's division like it always has been. Long division, we're going to take this divided by this to get the answer. So x cubed divided by x makes x squared. X squared times x is x cubed. X squared times y is x squared. Y doesn't match y cubed. So I'm just going to put that in the gap. I'm going to subtract. I always subtract this. Subtracting is changing signs. So x cubed becomes negative. X squared y becomes negative. X cubed minus x cubed cancels. Negative x squared y. And then plus y cubed. Still leaving myself some space here to account for terms that don't match the y cubed. As long as I still have x's in the first term, I'm going to keep dividing. Once I run out of x's in the first term, I'm done. So negative x squared y divided by positive x makes negative xy. Negative xy times x is negative x squared y. Negative xy times y is negative xy squared, which does not match y cubed, so it doesn't go underneath it. Next I subtract. Subtraction is changing signs. Negative x squared y becomes positive. Negative xy squared becomes positive. Negative and positive x squared y cancel. Xy squared is left. Leave some space. Plus y cubed. First divided by first. Positive xy squared divided by positive x is going to be positive y squared. Y squared times x is xy squared. Y squared times y is y cubed, which matches y cubed, so I'm going to put that right there. Subtraction is changing signs. This becomes negative. This also becomes negative. Positive xy squared minus xy squared cancels. Y cubed minus y cubed also cancels. Remainder 0. So there's our solution. Okay. My guess is I'll make it where it comes out remainder 0 on the test, so just kind of expect that. And that's the process each time. Make sure both signs change each time when you subtract. Number 6, we're supposed to graph this quadratic trinomial. And at this point, you're either in one of two boats. Boat 1, you know exactly what you're doing, you have no problems. Okay. Boat 2, you're struggling with these still. So I'm gonna try and focus on boat 2 people today. Try and make some more sense of this. I'm going to go through the same process. I'm just going to show my work a little differently. That might help. So let me first off, the vertex value of x is going to be the opposite of b, so that's positive 4, so we go negative 4 over 2a, that's 2 times negative 1. Negative 4 over negative 2 is positive 2, that's the x value of the vertex that I care about. I'm going to make a little bit bigger chart here. All right, x here, y here. There's my ordered pairs that I normally get. I'm just putting this middle column here that might help to organize our work a little bit better. Might see where things are coming from a little bit better. Okay, I'm going to put 2 right there. And again, whatever this number is, that goes right there. That's my vertex. I want smaller, smaller. That'd be 1, 0. Bigger, bigger, 3, 4. Now, here's where I want to change it up a little bit and kind of show you where things are coming from if you haven't figured that out yet. So, negative x squared plus 4x minus 2. All right. I'm just going to do it piece by piece down here. So, this term is just square x and then make it negative. So 0 squared is 0, make it negative, still 0. 1 squared is 1, make it negative, is negative 1. 2 squared is 4, make it negative, is negative 4. 3 squared is 9, make it negative, makes negative 9. 4 squared is 16, make it negative, so negative 16. So negative x squared just means to square x and make it negative. Plus 4x just means to add, so we're going to do plus, 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 plus. And we're adding 4 times x, so 4 times 0 is 0, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. And then minus 2 is just minus 2, so minus 2, minus 2, minus 2, minus 2, minus 2. Now, it doesn't matter what x equals, it says minus 2, there's no x on it, so it's just a constant value. So we have a quadratic term with a quadratic pattern. 0, 1 squared, 2 squared, 3 squared, 4 squared. It's squaring everything. We have a linear pattern. 0 plus 4 plus 4 plus 4 plus 4. We have a constant pattern, just adding a bunch of constants. So quadratic trinomial always has those three pieces: a quadratic term, a linear term, and a constant term. And that's how we're evaluating this. X's value affects both of these, but the constant is whatever it is. And then to get y, we simply have to evaluate each one of these individually. 0 plus 0 minus 2 is negative 2. Negative 1 plus 4 is 3 minus 2 is positive 1. Negative 4 plus 8 is 4 minus 2 is positive 2. Negative 9 plus 12 is 3 minus 2 is positive 1. Negative 16 plus 16 is 0 minus 2 is negative 2. So 0, negative 2, 1, 1, 2, 2, 3, 1, and 4, negative 2. There's our parabola. And our final step in graphing a parabola is to graph the axis of symmetry. It's a dashed line through the vertex. Make sure we do a dashed line, not a solid line. And it goes right through the vertex, and it has an equation. Axis of symmetry equation is x equals number, and the number it equals is whatever this number is. So that's how you write the axis. It's not axis, I've seen people putting this on their paper, AOS equals 2. That's not right. It has to be x equals 2. So a linear equation is a vertical equation. X equals number is how you write a vertical equation. And it's going through the vertex, so it's going to equal whatever the x value of the vertex is. So dashed line, draw it in there, and identify its equation. Number 7, find the number that's 5/9 of the way from 11 to 20. So we're starting here, we're ending here, and we're going that much of the way from there to there. So first off, I'm going to take 11, my starting number, plus my fraction times my end minus the start. Ending, starting. So 20 minus 11, that gives me direct distance. So if I go from 11 to 20, I'm going exactly 9 spaces to the right, so it's a positive 9, and that's what this represents. 5/9 times 9 is 5, 11 plus 5 is 16. Okay, last test I came out to a pretty large fraction. This one I'm making a little bit simpler, so expect to be a little bit friendlier problem than it was last time. Number 8. Solving a system of 3 equations with 3 variables. I can get rid of x, y, or z. I can make a decision what I think is easiest to get rid of. I think I can get rid of y pretty easily. So minus y plus y cancels if I add these two together. Minus y plus y cancels if I add these two together. So that's what I'm going to do. So if we start with the magenta pair, these two. I'm just adding the 2 equations together. Again, negative y plus y is going to cancel, so all's well with that. So x plus 2x is 3x. Negative and positive y cancel. Negative 2z minus z is negative 3z. And negative 7 plus 13 is 6. I happen to notice 3, 3, 6, everything divides by 3, so x minus z is equal to 2 is even a better equation. So I'm going to go with x minus z is equal to 2, created from 3x minus 3z equals 6, created from the addition of these 2 equations. If I take the blue equations, the top and the bottom, positive x, negative x happen to cancel. That can happen. Negative y plus y cancels. That has to happen. So again, I've already established y is going to go away, so I need to make sure y goes away again. But just x going away in addition, that's just a bonus. So negative x and positive x cancel. Negative y and positive y cancel. Negative 2z minus z is negative 3z. And negative 7 and negative 5 make negative 12. Negative 3z is equal to negative 12. Dividing both sides by negative 3 gets me z is equal to positive 4. Now, what I'm trying to do is figure out the values of x, y, and z. And what I want you to notice here is I've already found out what z equals. I've already got part of my answer. Okay? Once I know z is equal to 4, I can just substitute there. X minus 4 equals 2, so x is going to equal 6. And It wants to know x is equal to 6 and z is equal to 4. I can go back to any one of these equations. I'm going to go to this bottom equation. It says minus x, that'll be minus 6, plus y, we don't know yet, minus z, that's going to be minus 4, is equal to negative 5. And that's going to be y minus 10 equals negative 5. Move the 10 over, change the sign. Negative 5 plus 10 is positive 5. Okay. If this didn't happen where the x is canceled, I'd have something x, something z equals 4, something x, something z equals 2. Then I do elimination or substitution from that point to find both x and z. If you just happen to get x equals number or z equals number or even y equals number in this step, that's just, again, easier. Z equals 4, done. Substitute, find x, done. Find x and z. Go back and substitute to find y, done. Once you get all three, that's your answer. Number 9, graphing a system of linear inequalities. First off, this top one I'm going to do in red. It's a linear equation. So I've got a y-intercept of positive 3. So what I'm graphing is y equals negative x plus 3. Y-intercept is positive 3. Slope is negative 1. As a fraction, that's negative 1 over 1. So if I go down 1, right 1, down 1, right 1, and so on, I'm getting these points here. The negative slope going down from left to right. And I'm going to connect those dots with a solid line. Solid because it is less than or equal to. So solid line going that direction. The second inequality, I'm going to make it y equals x minus 3. That's a y-intercept of negative 3. And a slope is 1, positive 1. That's 1 over 1. So that means up 1, right 1 for each point. Then we connect the dots with a nice straight line. Once again, a solid line's happening here because in the inequality statement, greater than or equals to means solid line. Once we got both graphs done, I want to pick a test point, 0, 0 if available. If not, pick something with small numbers. 0 is nice because it's easy to add and subtract and multiply 0. So, if I go to my red inequality and I substitute x and y with 0, it's going to become 0 is less than or equal to negative 0 plus 3. That's 0 is less than or equal to positive 3, which is always true. Okay. So for the red graph, which is this red line, this point's true. The truth is on this side of the red line. So for the red line, I'd be shading this direction on that side of the blue line, and this direction on this side of the blue line. So here's my red line. There's the truth. The truth is that way. Do the same thing for the blue graph. If I put 0, 0 in for x and y, we put 0 is greater than or equal to 0 minus 3. That becomes 0 is greater than or equal to negative 3, which is always true. Alright, so there's my blue line. The point is true for the blue line, so everything for the blue line going that direction is true. So I put an arrow on either side of the red line, demonstrating the way I would shade for the blue line. So the truth for the blue is there, the truth for the red is there. That means the truth for everything is going to be in here. So that's what I'm going to shade in. Number 10. Our first priority on this type of problem is to take this thing out and fix it. So I got x on top, I've got 2 plus x over 3 on the bottom. This is the issue, so I need to do times 3, times 3, times 3. Everything times 3. So the top of this fraction here becomes 3x. This term becomes 6. Those 3's cancel, that becomes plus 6. This expression is equivalent to that expression. So this is my problem. I'm taking this out, putting this back in, and it becomes x over 1 plus this thing. Now, this has the exact same structure this had. We have a single object, not a fraction, a single object, not a fraction, and a single object fraction. That's what's happening here. Not a fraction, not a fraction, fraction. The common denominator of the only fraction there is just going to be 6 plus x, so times 6 plus x, times 6 plus x, and times 6 plus x. So, On top, x times 6, x times x. I'm going to get 6x plus x squared. On the bottom, 1 times 6, 1 times x. That just makes 6 plus x. This term here plus this thing, 6 plus x cancels 6 plus x, so it's plus 3x. That's the correct answer. I do happen to notice that we have some like terms. We should always add like terms when possible. So my best final answer is going to be 6x plus x squared on top and 6 plus 4x on the bottom. I would not count this wrong, but do look for like terms whenever you're dealing with simplification of fractions. Number 11, the 4th root of 25 times the 5th root of 5. So first priority on this. You want to leave the 4th root as it is. 25 and the 5th root of 5 are both going to be written as a number to a power, specifically the same number to a power. Starting with the blue, that's obviously 5, and that's 1/5 power. For 25, I know 25 is 5 squared. Okay, those are being multiplied together, so these are being multiplied together. It's very important. They have the same base raised to a power, so you get them both same number raised to some power to represent each of them. So 5 squared is the same as 25. 5 to the 5th power is the same as the 5th root of 5. Then, still a 4th root. Now I'm going to multiply these two things together. I multiply the same base by adding the two powers. So 5 is still going to be the base, and I'm going to do 2 plus 1/5. 2 is the same as 10/5. 10/5 and 1/5 makes 11/5. And I do want it to be an improper fraction. I don't want it to be a mixed number here. So make sure you actually create fraction form to create a nice improper fraction. And the final step, once you get the inside down to a single object raised to some fractional power, this root's going to multiply by that denominator to make the new answer. So 5 stays 5, 11 stays 11, 4 times 5 makes a new denominator of 20, and there's our simplified answer. Number 12. I keep saying this every time I talk about these problems, but some of you just aren't, you're not getting it, you're not trying to get it, I don't know what's going on. But whenever you see radicals in a problem in the directions say simplify, focus on the radicals that you're looking at and ask yourself, is there some way I can make that radical simpler before you start going through the process for the actual problem type? So there's a way to fix this problem type, but before I worry about that, I want to fix individual pieces as much as I possibly can. So, the square root of 20, 20 can be broken down to 2 times 2 times 5. We can take a 2 out. The square root of 20 and 2 times the square root of 5 are exactly the same. And 2 times the square root of 5 is simpler, so that's the form I want to have. So the top stays 3 plus 4 times the square root of 5. The bottom is going to be 6 minus 2 times the square root of 5. That's priority 1 on a simplification of radicals problem. If a radical can be fixed to be made simpler, you should do that first always. Once you take care of that, I can't make square root of 5 any simpler than what it is. Now I've got this structure issue. I don't want radicals in the denominator, so I'm going to multiply by the conjugate of the denominator. So 6 minus 2 times the square root of 5, conjugate is 6 plus 2 times the square root of 5. I got to multiply the top by the exact same thing. Basic rule of fractions, multiply the top and bottom by the same thing. You create an equivalent fraction, and the equivalent fraction will have the proper structure in this case. So, on top I'm just doing FOIL. First times first, positive 3 and positive 6 makes positive 18. Outside times outside, positive 3 times positive 2 square root of 5 makes positive 6 square root of 5. Inside times inside, positive 4 square root of 5 times 6 makes positive 24 square root of 5. Last times last, positive 4 square root of 5 times positive 2 square root of 5 makes 8 times 5, which is 40. So when you're doing this product here, this times this makes the 8, this times this makes 5, 8 and 5 make the 40. On the bottom, I'm just doing FL because the outside product 12 square root of 5, inside negative 12 square root of 5 cancels. So 6 times 6 is positive 36, and this times this, negative times positive makes a negative. 2 times 2 is 4, square root of 5 times square root of 5 is 5, 4 times 5 is 20. So I'm at this point, and what's left to do now is to make it as simple as possible. On top, adding like terms, 18 plus 40 is 58. 6 square root of 5 plus 24 square root of 5 makes 30 square root of 5. And on the bottom, 36 minus 20 is 16. That is the correct answer. This one happens to reduce because all three numbers divide by 2. If you don't reduce them, I'm not going to count it wrong, but again, it's stuff to look for. More you find stuff like this, the better you're going to be at math, so it's worth doing. But getting to this point demonstrates you know what you're doing on this problem. But reduce everything by 2, this becomes 29, this is 15 times the square root of 5, and this is going to be 8. That's the best answer. This is going to get you full credit, but do look to reduce when possible. Number 13, we have simplification of complex numbers. I see i's to powers in the problem. I see negatives inside of radicals. So my first priority again is fix the radicals as much as possible. Then I'll worry about all the I stuff. First fix for radicals is negatives in the radicals. So this is I times the square root of 7. That's being multiplied by another I times the square root of 7. This is going to be 5. And then, of course, I for the negative, I'll call this the square root of 36 for right now. Okay, so that's just fixing the negatives in the radicals. These two things aren't like that. So negative 4i to the 5th is fine for right now. Positive 4i to the 4th is fine for right now. Next thing I want to do is actually evaluate the radicals. Okay, so once again, I'm not doing anything with this, so it's still negative 4i to the 5th. Okay, for this thing here, square root of 7 times the square root of 7 makes 7. I times I makes I squared. For this, the square root of 36 is 6 times negative 5 is negative 30, I to the first. And then we have plus 4i to the 4th. Once I have every term looking like these two terms, some number times I to a power, some number times I to a power, some number times I to a power, and so on. Once everything looks the same, now I'm going to worry about my i's to powers. It's the same pattern we've been using for a while here. I to the first, I to the second, I to the third, I to the fourth. I to the first is I to the second is negative 1, I cubed is negative I to the fourth is positive 1, I to the fifth repeats back here. So, I to the fifth equals I. So negative 4i. I squared is negative 1, plus 7 times negative 1. 30i is 30i. I to the first is fine. Real numbers are fine. 4i to the fourth, I to the fourth is 1. So, this became I, this became negative 1, this just stayed I, and this became positive 1. Real number, real number. Negative 7 plus 4 makes negative 3. Imaginary number, imaginary number. Negative 4i minus 30i is negative 34i. And there's your final answer. In the correct order, real first, imaginary second. Number 14, adding vectors. So, negative 20 at an angle of 215. And we'll have positive 40 at an angle of negative 60. So we want to convert both of these vectors into rectangular form. So I'm going to do negative 20 cosine of 215 and negative 20 sine of 215. I'm going to do positive 40 cosine of negative 60 and positive 40 sine of negative 60. I don't know any of those values off the top of my head. I'm going to make sure my calculator is set to degrees, which it is. So if I just type in what I'm seeing there, negative 20 cosine of 215, negative 20 sine of 215. That gets me for the first vector, 16.38 horizontal, so I vector, plus 11.47 vertical, so that's J vector. And then the second one, if I do 40 cosine of negative 60 and 40 sine of negative 60, that comes out to 20i minus 34.64j. So I break them both into horizontal and vertical components. Cosine makes my horizontal, sine makes my vertical. I is horizontal, j is vertical. So, create the proper order there. I'm going to add them together. 16.38 plus 20 is 36.38. 11.47 minus 34.64 comes out to negative 23.17. Okay, that's good for half credit. If you give me that answer, half credit. To get full credit, you have to go back to polar form. So 3 steps of polar form. Step 1, the magnitude is going to be the square root of the square of these objects. So 36.38 squared plus 23.17 squared. Squaring creates positives 100% of the time, so ignore minus signs in that step. So square root of 36.38 squared plus 23.17 squared in parentheses equals 43.13. Step 2. Alpha is always inverse tangent of the absolute value. So absolute value, negatives again are irrelevant. Vertical over horizontal. So vertical 23.17 over horizontal 36.38. So I do hit second tan, and I do 23.17 divided by 36.38 in parentheses equals. Comes out to 32.49 degrees. Alpha again is a reference angle. It's not the answer necessarily. It just represents what we need to do to find the answer. To find the answer, we have to establish a quadrant and then do the proper equation for theta from that quadrant. To find quadrant, we look at the signs of these two things. I'm going horizontally positive, that's up to the right. I'm going vertically negative, that's down. If I go in the coordinate plane, if I go to the right and down, that puts me in the fourth quadrant. In the fourth quadrant, theta's definition is theta is equal to 360 minus alpha. That comes out to 227.51. Sorry, 327.51. And just for verification, 360 minus 32.49 comes out to 327.51. So, for full credit, there's my magnitude, there's my angle for my full credit answer. So 43.13 at an angle of 327.51 degrees. Okay, so, again, change in rectangular, get the rectangular answer, convert rectangular back to polar. Have this written on your paper. If you do this improperly, you'll still get half credit for that being on your paper. It's worth making the effort. If you try it out and get it wrong, you still have half credit there regardless. If all you do is stop there and take your half credit, that's not really trying very hard. So make sure you try and do it at least. Number 15, solve. This is one of our quadratic equations that we just recently done that is factorable. So if I like x squared positive, so I'm going to move the 5x squared over. So I'm going to get 0 equals 5x squared plus 3x minus 12. Now first off, the quadratic formula still works. If you want to use the quadratic formula, I'm not going to stop you. All right. If I don't want to use the quadratic formula though, if I want to look to possibly factor this thing, I'm going to get a factors of something and a sum of factors to be something. Okay. For factors of, I'm going to multiply these two things together, signs included. So 5x squared times negative 12 is negative 60x squared. And I want the sum of that to be 3x. So two numbers multiply to make 60, then add to make 3. I don't know if this works. I just go one at a time. So 1x and negative 1x and 60x makes 59x, obviously wrong. 2x, negative 2x and 30x is 28x. Negative 3x and 20x is 17x. Negative 4x and 15x is 11x. Negative 5x and 12x is 7x. Negative 6x and 10x is 4x. 7 doesn't go into 60, 8 doesn't go into 60, 9 doesn't go into 60, and 10 has already been taken care of. So it doesn't factor, so we do have to go to the quadratic formula. So if we're going to go quadratic formula on this, if I let A equal 5, B is equal to 3, and C is equal to negative 12, my answer is going to be in the structure of something plus or minus the square root of something over something. The something that goes here is the opposite of B. So B is positive 3, so I put a negative 3. What goes in the bottom is 2 times A is 5, 2 times 5 is 10. Those two mentally, I think we can all handle. Change the sign, double a number. The b squared minus 4ac is a little bit trickier, so b squared minus 4ac. B squared is going to be positive 9. B squared is always positive regardless of b's values. Be careful of that. Minus 4 times a, 5 times c, negative 12. This product will be positive or negative based on signs in the product. So there's 3 numbers being multiplied. 2 negatives make a positive. So 4 times 5 is 20 times 12 is 240. Add them up, you get 249. Just looking at 249, it doesn't look to be factorable. I think 3 times 83, 83 is prime, so it doesn't factor to anything simpler than that, so those are your answers right there.